that has the most overlap that almost everybody will be tested on. Okay, I think if not, let's just jump straight into it. So welcome everyone to the Sec 3 end of year revision package. I realize I've been doing a lot for the Sec 4s, but not much for the Sec 3s. So I put together this Friday night session where we can all spend it together to recap our content and just make sure we do sufficiently well for end of year. I think if you haven't been preparing, it's about too late, but let's just get this done so that you'll be even more ready. So just a brief overview of what you'll be expecting today. So just a brief introduction from me, and then we'll go on to do the chemistry topics. Once we are done with the chemistry topic, should be around 9 or 8:55 there, about halfway point. We actually have a midway point break. Here I'll share a couple more information about some of the upcoming stuff that's happening for Overmark. After that, we'll move on to the physics topics. So for the bio students, if you want to drop off after the midway break, feel free. But just take note that after the physics topics, which will end around 9:50, we'll actually have a giveaway contest and Q&A. So while you need not sit in during the physics topic, you might actually want to consider staying around, because the giveaway contest, the winner will actually walk away one set of Overmark's curated notes, either for chem or physics, up to the winner. Okay, so that would be the prize for the winner. At the end, we'll have a Q&A section where you can ask me anything related to science, related to academics, about life, whatever. I don't care, just ask me, right? Okay, so I think that's all for the overview portion. So just a bit more about myself. If you don't know me, if this is your first time, your friend dragged you down, right? To this session, I'm Daryl. So nice to meet you. I'm actually the founder of Overmark. This is something that I started last year during when COVID just hit during the pandemic and there was a lockdown. Oh my God, eerily familiar. But that was a period whereby I think a lot of students were struggling with adapting to home-based learning. And there was a demand for free notes. And I thought, why not just do what's in my capacity to help this student community? And I think after that, more tutors have joined on board, and Overmark is what you see today. And we are really excited to be providing academic materials, hosting such sessions for you guys, just to make your life a little bit easier, because I know school is not that easy. For myself, I've been tutoring for over 7 years, currently tutoring over 20 plus students. Just this year alone, we conducted our flagship crash courses, and I'm glad to have worked with over 200 students. They are entering their O levels just to make sure that they get more ready. And I'm proud to say that for all my private duties, they have done exceedingly well. And in today's session, I'll be hopeful to share some of the tips and tricks to make sure that you're able to score well for your end of year as well. Okay, so enough on the introductions, but before we move on, I just wanted to say something here. Okay, so I just want you to remember this. Luck is what happens when preparation meets opportunity. So to kickstart this session, I want you to know there's nothing such as luck when we're talking about exams or when doing well, right? So you need to remember it's only a prepared student that is given the right opportunity. That's when we call lucky. But lucky is nothing more than preparation. So later on throughout the session, I'll be telling you a lot of tips and ways to be prepared in terms of what kind of questions will be coming your way, what things to look out for. So using this preparation, I hope that you will be more equipped to do well for your end of year and potentially for your O level as well. So let's get straight into it. Okay. So you'll be seeing me moving over to another soft copy of a material. So that is actually the soft copy of the curated notes. From time to time, I would be referencing that. If you don't have the curated notes, it's fine. If you have it, great, you can refer to it. But if you don't, just take down whatever important pointers you would want beside your school notes. That would be very helpful for your revision. Okay, so if not, just take down your textbook and notes and write down. It is completely fine. All right. Now, let's talk about what we'll be covering today for chemistry. Just take note that I won't be covering every single nitty-gritty detail, because some things I would sort of really expect you to know the basics. So I'm just covering more of the ones that will be a bit more examinable, which means they have a higher likelihood of appearing at your end of year exam, and also the more complicated concept. Okay, but take note, these are just the key points. So this will be purely about the key overviews. Okay. Please do not annotate on the screen, yeah? Okay, okay, if there are no further questions, okay, I'll kickstart the session. Is it okay for N-level students to join? Of course. This will also be uploaded on the YouTube channel. If you're A-level student, I mean, lols, you don't have to be here. Okay. Okay, guys. So don't annotate on the screen, yeah. Okay. Now let's jump into the first chapter for today, which is atomic structure. So under atomic structure, I will be covering a couple of key concepts in subatomic particles, ions, and isotopes. Now let's jump straight into it. Okay, so for subatomic particles, you need to note that there are a total of 3 subatomic particles within our atom. Why is it called subatomic? Because these particles are within your atom. They are smaller than the atom itself. So the 3 subatomic particles are your protons, neutrons, and electrons. Now, I want you to take note of the location. For the charges, I think you all know, proton +1, electron -1, okay? But pay attention closely to the location in which these subatomic particles are found. Now, I need you to note that for protons and neutrons, they're actually found in the nucleus. So if the question comes out and they use this term nucleon number, I want you to know that they're referring to the nucleus. And what is inside the nucleus are your protons and neutrons. So when they're talking about your nucleon number, just take note, okay, is your proton plus your neutrons. Your electrons are, of course, found on your electron shells, okay? I think I don't have to say, right, 288, you all should kind of know how that works already, all right? In terms of the mass of an atom, take note that electron is not that it doesn't have a mass, but electron's mass is so small, we call it negligible, which means I can kind of ignore that the electron has a certain mass, but it's not that it has 0 mass, it's just that it's negligible. So whenever we're dealing with terminologies like atomic mass, we're actually referring to the number of protons plus number of neutrons combined. So to break it down further, right, here we see magnesium, right? It has a mass number of 24 and it has a proton number of 12. So take note, whenever you check your periodic table, you'll get 2 numbers, the bigger one and the smaller number. The bigger number is referring to your number of protons plus neutrons. Okay. Meanwhile, the smaller number is always for your protons only. Take note that this small number is also equivalent to your number of electrons, right? Because number of protons is equal to number of electrons. So if I have 12 protons, it means that my electronic configuration should be 282 to add up to a total of 12 electrons. Okay, but life is not going to be so easy. They won't just stop at your proton, neutron, electron. Under atomic structure, you're also required to know your ions. So there are 2 kinds of ions, namely your cation and your anion. Take note, for your cation, these are referring to your positively charged ions. Okay. Meanwhile, your negatively charged ion is known as a anion. Now, if you pay attention, right, if you can't remember, is cation positive or negative? Do you see the T here? The T, right, you just think of it as like a plus sign, right? That is positive. Meanwhile, anion, do you see the N here? The N is like negative. So this is just a way to help you make your life easier when you're studying. Okay, but of course, I think if you've done this chapter sufficiently, cation and anion should come quite naturally. Okay, especially since you've been doing science for the last 3 years already. So I doubt this is something too foreign for you. Okay, but atomic structure, the biggest concept that will be tested would be isotopes. Okay, so now if you have your school notes with you, make sure you put an asterisk here. There's a very high likelihood that your end of year exam will require you to define isotopes. Okay, so isotopes are atoms of the same element. They have the same number of protons and electrons, but they have different number of neutrons. Okay, what do I usually teach my students when I say isotopes? I usually tell them, just remember that isotopes are like twins. They are the same technically. The only difference is that one is heavier. So there's 2 twins and one is fatter, right? So if we take a look at the example here, we have carbon 12, carbon 13, and carbon 14. Note that all 3 carbons, they are all carbon. Okay, why do I say that? It's because they all have the same number of proton. If you have 6 proton, it just means you're carbon automatically. Okay, but then maybe carbon 13, right? It went to eat KBBQ. Then carbon Tin, right, went to eat mukbang challenge. So you see that they are heavier, right? Because they have more neutrons. But at the end of the day, they are still brothers. They are all carbon. But just that two of them are heavier. Heavier in terms of what? In terms of neutrons. So that is what an isotope is, okay? Atoms of the same element, different number of protons, but same number of neutrons. So make sure when you're giving your definition, you're accurate in that sense, okay? But beyond that, I need you to realize that this is a very foundational, fundamental way of understanding isotopes by memorizing a definition. Rather, I want you to understand beyond that, what the school can test you would be about the chemical and physical properties. So what about the chemical property? You need to note that isotopes, they actually have the same chemical properties, or you can use the term similar, it's fine. All right, same idea. But same similar chemical properties, why is that the case? I don't want you to just memorize here, but I want you to understand. All right, so let's use magnesium because we were using it earlier. Is 282, correct? So now, for magnesium itself, whether it is magnesium 2412 or magnesium 2512, they both have the same number of electrons. Therefore, they have the same electronic configuration. So what will magnesium try to do? 282, right? 282 is annoying. What does it want to do? It wants to get rid or give away 2 electrons. That will allow it to have a stable electronic configuration. So whether it is your magnesium 24 or magnesium 25, both of them would be trying to give away 2 electrons, which means the kind of chemical reactions they undergo would be similar, right? It's going to be a chemical reaction whereby they can give away 2 electrons. Since they undergo similar chemical reactions, we will expect them to have similar chemical reactions. Okay, so yeah, cannot highlight, but never mind, you'll get the idea. All right. Meanwhile, you need to note that isotopes would have different physical properties. When I say different physical properties, is referring to things like density and melting boiling point. Why is it different? It's because their mass is different, right? Because they have different number of neutrons. That would directly lead to the fact, okay, that they will have different physical properties. Remember, one is fatter, physical property will be the same, but the chemical reactions they undergo would be the same. So take note, if this appears in your exam, I need you to know clearly that beyond just the definition, you should be familiar with the chemical and physical properties, whether it's same or different, and how you should explain it. Okay, so I put a bit of emphasis on isotopes because it tends to be tested a little bit more. Okay, beyond that, okay, something else you need to know about isotopes would be the fact that isotopes, we are all talking about average mass. So if you flip your periodic table, you would notice that, okay, your chlorine's AR is actually 35.5. Okay, why is it 35.5? Okay, it's because what we're dealing with here is not that there is 0.5 neutron, okay, but rather what is happening here is that chlorine, we know there's chlorine 35 and chlorine 37. Now, do they exist in equal proportions? No, they actually exist in terms of almost 76% of chlorine exists as chlorine 35, 24% of chlorine exists as chlorine 37. So when we calculate the average mass is around 35.5. So the mass that you see in the periodic table, right, that 35.5 and 17, right, this 35.5 is not that it has half a neutron. That is not true, okay? It's not half a neutron, but rather this is a representation of the average mass. So just take note of this and I think you'll be fine. Okay, so isotopes, take note, okay, keyword average mass, because there are different versions of chlorine. All right, so that's for atomic structure. But before we move on, let's do a quick quiz. Okay, so boron 3+. Okay, so how should we go about solving this question? Okay, we go statement by statement, as if how we would do in an exam. Okay, so if you flip to your periodic table, you will see that boron is actually 11 and 5. What does this 11 and 5 mean? Okay, 11 means 11 is proton plus neutron. 5 means 5 proton. 5 proton also means 5 electron. Okay, but take note, this is not just boron, but it's boron 3 plus ion. Okay, think about it. So how many protons do I have? Protons, I got 5. Neutrons, I got how many? 11 minus 5. I got 6 neutrons. Right? Because the atomic mass is proton plus neutron, that's 11. I only have 5 proton. That makes it, I have 6 neutron. What about electron? How many do I have? I originally started off with 5 with an electronic configuration of 2, 3. But now 3 plus. What does it mean? If boron is 3 plus, it means that I gave away 3 electrons. And when that happens, I have more I have more proton than electron. Therefore, my charge is 3 plus. So originally I had 5. I gave away 3. I'm left with 2 electrons. Okay, so this is how you should analyze and break down your question if you see a similar question. Okay, now if we take a look at all the options, let's see whether they make sense. The ion contains 10 subatomic particles. Subatomic means proton, neutron plus electron. We can see it's a total of 13. So this is not true. Boron gained 3 proton to get a charge of plus 3. Now, this is a very common misconception, okay? But the truth is that protons would never move. When we are talking about gain and loss, it's always about the electron. So if I'm a charge of 3 plus, it just means that I gave away 3 electrons, not that I gained 3 proton. Okay, remember, proton don't move, only electron moves. Okay, isotope of boron will have different number of proton. Not true. Remember, isotopes just means twin but factor. Proton is always the same, but I might have more neutron instead. Okay, so statement C is also not true. There's more neutron than electron. 6 versus 2. That's of course true. So answer should be D. Okay, so if this appears in your exam, make sure you break it down into how many proton, neutrons, and electrons there are before you follow up to see whether the statements are true or false. Okay, always very helpful. Okay, next we'll be doing chemical bonding. Okay, so under chemical bonding, take note that for us, we will be seeing a couple of, sorry, please do not annotate on the screen, yeah? Okay, so under chemical bonding, we have ionic, covalent, and metallic bonds. Okay, for my combined science students, just take note that you will only be tested for ionic and covalent bond. Metallic bond is purely for pure science. Okay, so I'll highlight to you all the difference later on, but let's jump straight into it. First thing first, okay, we have our ionic bonds. What I need you all to remember is that ionic bond is always between metal and non-metal. Must know, okay? Because metal typically have excess electron on the outermost shell, for example, like sodium. Sodium's electronic configuration is 281. Chlorine's configuration is 287. Can you see? This is a relationship that works. Why? Because the sodium is like, I want to give away an electron. And then the chlorine is like, I want to be 288, right? So I want to gain an electron. So when that transfer of electron happens, you get a cation and you get an anion. That electrostatic force of attraction is what forms your ionic bond. So typically ionic bond, it must always be between metal and non-metal. Okay, now the structure that would be formed as a result is known as your ionic lattice structure. It will be held together by strong electrostatic forces of attraction between your oppositely charged ions. Okay, so this is a keyword. Now take note, this chapter is really about your keywords. The more keywords you put in, the more likely you're going to score well in the exam. So the first keyword that I'm highlighting here is your electrostatic forces of attraction. So just take note, okay? In terms of physical properties, there are 3 main ones that usually come out in the exam. They include melting boiling point, solubility, and electrical conductivity. Now, how do we justify that ionic bonds have high melting boiling point? You should explain in terms of the fact that it has a giant ionic lattice structure. Within this structure, there are strong electrostatic forces of attraction between oppositely charged ions. Large amount of heat energy is required to overcome these ionic bonds. You see? So in essence, right, when a teacher is marking your paper, they're not going to look at your full sentence. What they're going to be focusing on is whether these keywords appear. Mention the structure mention the forces of attraction and whether it requires large amount or small amount of heat energy to overcome. That's how you justify high or low melting boiling point. Okay, so ionic bonds, high melting boiling point. Okay, note that for ionic bonds, they are all soluble in water, so they do dissolve in water. Okay, on top of that, you need to know that they do conduct electricity. But take note, ionic compounds do not conduct electricity in solid state. They only do so when they are in molten and aqueous state. Okay, the question is why, right? In solid state, we learn that the particles will be held in their fixed position. If they are stuck in their rigid fixed position, they are not able to help you transport electricity, which means they cannot conduct electricity. But in molten and aqueous state, the ions are free to move. If they are free to move around, then life is great. They can help you transport electricity from point A to point B. Okay, so electricity conductivity is all about whether there are mobile ions or mobile electrons that could help you conduct electricity. Okay, so in this case, right, molten aqueous state, yes, the ions are free to move, functioning as mobile charge carriers, therefore allowing it to conduct electricity. This is a very important point. Okay, note, so what will happen is that the question could come up with various properties. It tells you that this substance has high melting boiling point. It dissolves in water and it can conduct electricity in molten and aqueous state. What you need to do is to do a reverse deduction. If it has such properties, means it's probably a ionic compound. Okay. Another way they can test you is they ask you, ionic compound can conduct electricity or not, right? In your structured question. Then you need to say cannot conduct electricity in solid state, but can do so in molten and aqueous. Yeah, so there's a few ways you could go about testing you, but at the end of the day, in terms of what you need to take note of would be these three physical properties. Clear? Anyway, I know there's a lot of people, so you might be shy in terms of asking questions, but don't worry, we won't expose your identity. You can just type in the chat. Okay. What about gaseous state? No, gaseous state does not conduct electricity because they fly away already, right? There's no moving thing. They are all existing in gaseous form. Okay. Anyway, ionic compounds rarely exist in gaseous state. Okay, because of their high melting boiling point. Okay, good question. What does molten mean? Molten just means liquid. So solid, liquid, gas, right? Molten is just liquid state. It's just like O-level 1 to fancy lah. They're like, molten state instead of liquid state. Yeah, but that's about it. Okay. There are some ionic compounds that will be insoluble in water. That will depend on your salt solubility table, which we will touch on later. Okay. I got a good question from Chloe here. You're asking whether is it free moving electron or free moving ion. This is a very good question. Okay. So earlier I mentioned that there will be a total of two possibilities. If something can conduct electricity, is because either it has free moving ions or free moving electrons. On Earth, the only material that has free moving electrons are metals, which is why metals can conduct electricity. But if you're justifying for ionic bond, it's always about free moving ions. There are no free moving electrons. Okay, liquid molten state is the same thing. The difference between molten and aqueous state, there's a difference. Molten state just means solid state. Okay, but aqueous state, what it means, right, is that we add in water. Okay, so I give you an analogy. Ice cream haven't melt, right? You buy your ice cream, damn nice. That is solid state. The ice cream drop on the floor, it melts, that is liquid state. If I pour water over and mix it with the ice cream, that is aqueous state. So there's a difference between molten and aqueous. Okay. I'll move on from here to talk about covalent bonds. Okay. So the next thing you want to know, remember ionic bonds, metal, non-metal. Covalent bonds is between non-metal and non-metal. So covalent bonds is a matter of sharing electrons. As you can see in the diagram here, right? So the chlorine, they're very nice. They 287, 287. Then they're like, bro, how? Right? Then they're like, okay, you know what? Let's just share one electron each to get a pair. Then we both share this electron. Now everybody happy. Everybody got 8. Okay. Or in this case, the oxygen was 26. Then they share a pair of electrons each with hydrogen. Then life is great. Everybody have their fully filled shell. Okay. So covalent bond is about sharing of electrons. Now, the keyword here, earlier we used ionic lattice structure. Here we need to use simple molecular structure. Okay, simple molecular structure is what allows, okay, not what allows, but it is the structure for covalent compounds. Okay, take note of the definition here, not definition, but the keyword. You note the keyword here is weak intermolecular forces of attraction. Okay, now I'm going to address this misconception or very commonly made mistake, and I want you to pay attention. So when we talk about ionic bonds, right, we know high melting boiling point. Why? Because we say that the ionic bond is very strong, right? And when we talk about covalent bonds for your simple molecular structure, you see here is low, right? So we think, okay, low melting boiling point. That means the covalent bond is very weak, right? So that would be a natural deduction based on logic. But take note that that is actually a misconception. I want you to pay attention to this diagram you see here. Okay, now take note, when we are trying to melt and boil something, it's all about changing it from closely packed to loosely packed to far apart. What we are breaking, right, is this thing called the weak forces of attraction between your molecules. Okay, this is known as your weak intermolecular forces of attraction. So between one NH3 and another NH3 molecule, it is very easy for me to break this attraction between them. But take note, within the molecule, between N and H, this covalent bond that they share, this covalent bond is actually a very strong bond. This bond will not be broken. Okay, so what I want you to remember here is that when we are justifying why the melting and boiling point is low, we are not trying to break the covalent bond here. All we are trying to do is to overcome the weak intermolecular forces of attraction. That's all. So in your answer, you need not mention and you should not mention anything about covalent bonds, because what we're overcoming is the weak intermolecular forces of attraction, the forces of attraction that exists between these two molecules and this molecule. But what we are not breaking is we are not trying to break the covalent bonds within the molecule. Clear? I hope you get the difference. There's a big difference here. So this is where a lot of students make mistakes, and I don't want you all to go through the same pain point. Okay. Sometimes in school, they say fully filled valence shell, some say stable electronic configuration. It's largely the same. You should, for me, I prefer to use stable electronic configuration. Okay, it's the same thing. All right. What else to take note? Okay, covalent compounds, they are largely insoluble in water. Okay, please remember to mute yourself. Okay, electrical conductivity, they do not conduct electricity. Okay, so that's for your covalent bonds. Okay, for my combined science student, this is all you need to know for this chapter. Okay, now what is happening on the next few slides are more for the pure science students. Okay, for my pure science kids, just take note that for covalent bonds, it does not stop at simple molecular structure. You need to know your giant molecular structure. There's total of 3 of them. There's your diamond, silicon dioxide, and there's your graphite. Okay, note that for them, right, the properties are rather different from your simple molecular structure. They actually have high melting boiling point, because what we're actually overcoming here is the actual covalent bond. Okay. Okay, so the high melting boiling point is justified by the fact that the covalent bonds are very strong, therefore requiring a large amount of heat energy to overcome. Okay, they are still insoluble in water and they do not conduct electricity. But take note, graphite does conduct electricity. So diamond, silicon dioxide, graphite, only graphite conducts electricity. Why is it able to do so? Okay, let me head over to the curated notes just to showcase the portion here. Okay, for those that just joined and missed out, what I'm showing here is just the curated notes, okay? It's just a soft copy version. Okay, those that have it, you can flip with me to page 36. So for graphite, I need you all to recognize that it can conduct electricity because for a graphite, when they form bonds, do you notice one carbon atom is bonded to only 3 other atoms? Because of the hexagonal structure, right? So in that case, because carbon's electronic configuration is 2, 4, if I only have 3 that's involved in bonding, there's a 4th electron that is delocalized. This delocalized electron can function as a mobile charge carrier to help you conduct electricity. So this is the reason why graphite can actually conduct electricity. but it's due to the delocalized electron. Okay. If not, I'll jump back to the slides. Okay, so that is your giant molecular structure. Okay, next, let's move over to metallic bonds. Okay, so for metallic bonds, take note, the correct way to describe it is the electrostatic force of attraction between the lattice of cations and the sea of delocalized electrons, as you can see here. Okay, metals, we know that they have high melting boiling point because this metallic bond is very strong. Okay, we know metals don't dissolve in water, and we know that they conduct electricity. Why are they able to do so? Is because the sea of delocalized electron function as mobile charge carriers. Okay, metallic bond is for pure science, so if you're taking combined, you don't have to be worried about this. Okay, so I hope I made it clear. This chapter, there's a lot of keywords. This should be the chapter you'll be spending a little bit more time on the day or a few days before your exam, just to make sure you get your keywords grounded. Okay. Okay, if not, I'll move on next to mole concept, right? Mole concept is a big pain in the ass, but we have to do it. Okay, so for mole concept, I'm not going to go through the content as much because the content you can read through your textbook, right? Pretty straightforward. What I'm about to share is more of how do you answer and attempt questions in terms of balancing your chemical equations. How do you write an ionic equation? And how do you do your chemical calculations? Okay, so let's go through and start off by talking about your chemical equations. So earlier, you already asked me the question, so I don't have to explain here. Solid, liquid, gas state. Liquid is the same thing as molten. Okay. Aqueous state means water is added. Okay. Aqueous will come in very relevant when we talk about acid bases later on. Okay. Now, when we are balancing equations, okay, students typically ask me, right? If you haven't learned more concept, you can just listen through. Okay, your school will teach it soon. This is one of the more important chapters anyway. Okay. Regardless, when you're balancing equation, the best technique to use, right, is to balance using the least common element first. Now, let's take a look at this combustion equation, okay, and break it down further in terms of what's the best practice when it comes to balancing your equations. Okay, so we take a look on the left side and on the right side. I want you to notice that the carbon only appears once on the left and once on the right. What this means, right, is that I should go ahead and balance this first. You notice? Because if I have 3 carbon on the left side, it means I'll get 3 carbon on the right side. So I should add in a 3 for my CO2. Next, the least common element will be hydrogen because hydrogen only appears once on the left and once on the right. It appears as H8 here. So if my compound here is H2O, I will need 4 of H2O in order to make it balance on both sides, such that there is 8H on both sides. So that's why I add in a 4 here in front of my H2O. Okay, the last thing I should balance should be oxygen. Why? It's because oxygen appeared in CO2 and oxygen appears again in H2O. So I leave this to the last. Now that I have balanced everything else, 3O2, 4H2O. How many O do I have on my right side? 6 plus 4, right? I have 10. So that's the reason why I write a 5 here. That's why, and in that sense, okay, that's how we balance our equations. Okay, I'll give you all tips, okay, just chill. Okay, even for NA, there is more concept. Okay, so just take note that this applies to across all levels. Okay, so this for balancing equation, this is the tip that I'm hoping to share with you guys. That is to balance using the least common one first. But at the end of the day, I think most of the time, all you need to really remember, okay, is you just need to check after you balance, just make sure that everything on both sides is equal before you move on, right? So some of you mentioned that it's literally like math. That's true, right? So you just need to mention that your equation here is balanced. Okay, so next, let's move on. Okay, so rather than just saying, right, balancing equations, why not let's try a question together, right? So in a situation whereby we get the question like this, which in any case, right, could actually come out for your exam. Okay, how should we do this? Okay, remember the tip to balance using the least common element first. But you notice in this question, everything only appears once on both sides. So in fact, I can balance this in any order. Okay, now when we take a look at this equation, let's say if you want to start balancing, how could we do it? Okay, let's write the number above each molecule. Okay, Now, we start off maybe with N. There is one N on the left side and two N on the right side. So what do? If my Y is 1, my W has to be 2, right? Because I need twice, I need 2 moles of NH3 to balance out 1 mole of N2. So I write 2 and 1. Okay, next. If I have 2 moles of NH3, how many hydrogen do I have in total? 2 times 3, right? I will have 6 hydrogen. 6 hydrogen, that means Z has to be a value of 3, right? Because 3 times 2, that's 6. Now, if I have 3 H2O, how many O will I have? 3 O. So how many O2 must this be? 1.5. Can follow not? 1.5 times 2, that's 3. Okay, but what's the problem here? The problem is that at O level, we cannot leave it as 0.5. A levels we can, O levels we can't. So what do we do to the entire equation? We take the whole thing and we multiply by 2. So my value should be 4, 3, 2, 6. That is the proper way of doing it. So it's completely fine if you talk about, hey, it's like 1.5. Leave it as 1.5 first. After you're done with everything, you multiply the entire thing by 2. Okay, that's why the answer here, okay, if I'm not wrong, 4, 3, 2, 6, right? Answer should be C. Okay, so in the exam, if you're required to balance equation, you can follow me through a similar step process. Okay. Next, right, let's take a look at the ionic equation. Okay, how do we form ionic equations? Okay, so for ionic equations, just take note that when we are doing it, okay, usually you're required to go from a chemical equation, okay, and then you convert it, okay, to an ionic equation. Now, I see some questions about acids and alkaline. Yes, we'll talk about that later, which is why I'm not addressing some of your questions yet, because we're doing acid bases later on. Okay, now for ionic equations, take note that there's a step-by-step way to convert a chemical equation to ionic equation. This is one of the most common weaknesses that I see among students, that they're uncomfortable with ionic equations. But today I'm going to make it so simple to you that next time you can do it. Okay, should we include state symbols for ionic equations? We should. Why? Is because you see here, the moment you write in your state symbol, the whole process becomes so much easier. Because what we are required to do here is that for anything that is in equal state, we convert it into its ionic form. What do I mean? You take a look at the first compound, BaNO3. BaNO3, when we dissolve it, it becomes Ba2 plus and NO3 minus. So this is what I mean by converting your compound into your ionic state. Okay, next, copper sulfate change from copper sulfate to Cu2 plus and SO42 minus. Okay, take note, see barium sulfate here, this is solid state. If it's solid, liquid, or gas, we don't touch it. Remember, ionic equations, we only break down those in aqueous state. Okay, so BaSO4, I write it as it is. Then copper nitrate, same thing. Change it into ionic form because it's in aqueous state. What do we do next? We need to remove spectator ions. Now, what are spectator ions? Spectator ions are basically people that sit there watch show. They just watch the show. Oh, wow, equation, wow, chemical reaction, very exciting. Then they, after the whole show, they start clapping. But all the time, they're just sitting there and they are chemically unchanged, which means they, before that, they are NO3 minus. After the whole reaction, still NO3 minus, which means they essentially did not react. That's why we eliminate, okay, things like NO3, Cu2 plus on both the reactants and product side. What remains is your ionic equation. That's all. So from chemical equation, anything that aqueous state, break it down, get rid of spectator ions. That is essentially how you do ionic equations. Now, how do you know the state symbols for the different compounds? This one will require a basic understanding of acid bases and salts, right? BaSO4, if I will be allowed to jump a bit, barium sulfate is an insoluble salt, which is why it's written as solid state here. Okay, how do you know the charges? You could check the periodic table. For example, barium's in group 2. That's why it has a charge of 2 plus, because it tends to lose 2 electrons. Meanwhile, for your anions like NO3 usually have a charge of minus. Okay, Yes, spectator ions should be cancelled away. All right. Solid, liquid, gas state would depend on their melting boiling point at room temperature. Okay. Transition metals have variable oxidation state, but I think that would be better addressed when we discuss metals in the future. Okay. Is it right to say that ionic equations is a simplified version of a chemical equation? Yes, ionic equation pinpoints what's the exact thing that reacted within your chemical equation. Okay, that's about it. So I'm going to move on from ionic equations next to mole concept. Here you see a bunch of formulas, right? A lot of formulas. I see already, I also headache, okay? But you need to know all of them, okay? But what we're going to do here is I'm not going to go through one by one. You can read the equations yourself. What I'm going to do is actually to solve questions alongside you to see how do we apply these formulas to an actual example and actual question. Now, let's start off with this first question, okay? The question is asking us to find the volume of hydrogen gas that will be formed when 48 grams of magnesium metal will be reacted, okay? To solve this question, you need two formulas. You need to understand, okay, and learn how to calculate mole. On top of that, you also need to know that 1 mole of any gas is 24 dm³, okay? What I have done here is that I've broken down mole concept into 4 simple steps that could be used to solve any question. So follow me through on this. If the question doesn't give you anything, okay, you need to write out your own balanced chemical equation. Okay, so you're required to do this step by yourself. Okay, balancing, we talked about it earlier, balance using your least common element first. Okay, so after you write in the balance equation and you check that's correct, in step 2, we always need to calculate mole. Okay, in this case, since the question gave us 48 grams of magnesium, what I'll do is I'll take 48 grams divided by the MR of magnesium, which is 24. That gives me a mole of 2 moles of magnesium. Okay, and when I know that, in step 3, what I'm doing is I'm going back to step 1 to take a look here. Do you notice that for 1 mole of magnesium, when I react it with hydrochloric acid, I'll produce 1 mole of hydrogen. Why do I say so? It's because here, in front of magnesium, there's no number, which means the number is 1. 1 mole of magnesium will react to produce 1 mole of hydrogen. So 1, 1, that means if I really have 2 moles of magnesium, I will produce 2 moles of hydrogen. Okay, so this is what step 3 is about, to compare your mole ratio. Which means in step 4, now that I have my number of moles of hydrogen, all I need to do is to take my number of moles multiplied by my 24. Why 24? Because 1 mole of any gas is 24 dm³. So the volume of hydrogen gas that I should get is 48 dm³. How do you know hydrochloric acid is aqueous? Hydrochloric acid, if it's acid, is always aqueous state, because all acid needs to dissolve in water to dissociate to produce H+ ions. Okay, I saw some other questions here and there. I'll try to address. Excess means I put in more acid than needed, but this is to ensure that all my metal would fully react. Okay. All right. Next, another question here. This one is slightly more challenging because it deals with percentage purity. Okay, so the formula needed for percentage purity looks like that, whereby the mass of your pure substance is over your mass of your sample, okay, times 100%. Okay, now, same thing, the question was so unkind here. They didn't give us the chemical equation, right? Annoying, right? But it's fine, right? Because what we have to do is we write out the own equation. Okay, if you're wondering how I derive at this equation, we'll cover it later on when we are discussing acid reactions. We should know that acid plus carbonate should give us salt plus water plus carbon dioxide. Then it's up to your own discretion to learn how to balance it properly. Okay, for step 2, what do we do? The question told us that 12 dm³ of colorless gas was formed. Okay, so for 12 dm³ of colorless gas, what do we need to know? 24 dm³ is 1 mole. So if I take 12 divided by 24, I can acknowledge that, hey, I have 0.5 mole of carbon dioxide. Now, if I have carbon dioxide 0.5 mole, you compare the mole ratio of carbon dioxide with calcium carbonate. Do you see it's 1:1? Which means if I produce 0.5 mole of carbon dioxide, I will get 0.5. I should have reacted 0.5 mole of calcium carbonate. Okay, that's why if you go and calculate the mass of calcium carbonate and put it back into the equation, you should be able to find out that the percentage purity is 50%. Okay, so you should always find the mole in step 2 and compare the mole ratio in step 3. Okay, so this is generally the flow for mole concept, whereby it's always a step-by-step kind of thing. So finding mole is very important because this chapter is called mole concept. No matter what question you do, it deals with mole, right? Okay, but this is only the tip of the iceberg. I'm only sharing some of the more basic examples. What you will be tested at O level would be much varied. Okay, yes, nitric acid is HNO3. I think this one you can change to HNO3. But the answer does not change. Okay, so a small typo here. But at the end of the day, right, the steps still stays constant. Okay, these 4 steps are accurate. Okay. But for mole concept, you guys really need to go and practice more. Okay, this mole concept is one of the most important topics in chemistry itself. The bad news here is that mole concept could apply to other chapters too, as like an add-on. Mole concept is basically the math of chemistry. So you really need to spend more time to do your practices here, okay, to make sure you get it right. Okay, I'll try to briefly explain what is excess and limiting reagent. Excess means I add in too much of it. So in this case, right, between magnesium and hydrochloric acid, when I say I add in excess hydrochloric acid, what this means, right, is that my magnesium now becomes my limiting reagent. Limiting reagent has the name limiting reagent because I don't have enough magnesium to go around, right? So my magnesium is limiting me from producing more of my chemical reaction. So the one that is insufficient is limiting reagent. The one where I just spam and add in a lot, that is in excess. Okay, so that is how we define excess and limiting reagent. Of course, I wish I could go through in detail, but as I shared at the start, okay, this is more of a brief overview so that you get a recap of all your key topics. Okay, if not, okay, next we are down to acid bases. Okay, so acid bases, salts, then we are done for the chemistry portion. Okay, now let's push on first. This is a must know. If you don't know this and you go into your exam, you're gonna die. Okay, so take note, there are a total of 3 acid reactions: acid metal, acid base, acid carbonate. Okay, I hope you are familiar with most of them. You need to know between acid metal, it produces salt and hydrogen gas. Acid base, this is known as neutralization, gives you salt and water. Acid carbonate gives you salt, water, and carbon dioxide. How do we test for carbon dioxide gas? We bubble it into lime water, we should get a white precipitate. Okay, cannot use chalky anymore. Chalky is for lower sec or primary school. We say white precipitate. Okay, neutralization is strictly used for acid base or acid alkaline reaction. So we don't say acid carbonate as a neutralization reaction. Okay, so take note, if you are not sure, this one confirm in your textbook or your school notes. Okay, make sure you study this. Okay, hydrogen gas, okay, it should extinguish with a pop sound. Okay, this one is the underrated one. While we typically know alkaline reactions, okay, I need you to know, okay, alkaline reactions, there's 2. The first one is neutralization. This one is easy, right? Acid, alkaline, neutralize. Okay, next, okay, as alkaline with ammonium salt. This is the underrated one. Okay, so if you're flipping through your school notes, I want you to put an asterisk, underline, double underline. Doesn't really matter, but just make sure that you get this right. Okay, now for an alkaline and ammonium salt, okay, take note that the reaction will give you a salt, gives you water, and it also produces ammonia gas. Ammonia gas is the only gas within our syllabus that is capable of turning something from red to blue. Okay, so take note of this equation. I'll show your actual question that could be tested based on reaction 2. Okay, just take note that this is important. Now, one of the more important questions that you must be prepared for your end of year is the difference between a strong and a weak acid. Okay, for strong acid, just note that there's only 3 of them within our syllabus: hydrochloric, nitric, and sulfuric. But in terms of definition, okay, we define strong acids as acids that dissociates fully in water, while weak acids dissociates partially in water. Okay, so that's the difference in terms of how you would identify or define the difference between the two. Okay, this can be easily tested, okay, in the exam. Okay, and I hope you can score that, okay, and get that right. Partially ionized, yes, is weak acid. Okay, take note, you can use the word dissociate, you can use the word ionize as well, but you cannot use the word dissolve. Okay, dissolving is turning from solid to liquid state. Ionizing is turning from a compound into ions. There's a difference in that. Okay, so the precision of your keywords matter too. Okay, dissociate, ionize, either is fine, but do not use dissolve. Okay, dissociate just means that something split apart. It's like what's associate? Associate is we put two things together, right? Dissociate is just the reverse. Okay. Now, one of the questions that I saw in the chat that I didn't really address was the difference between base and alkaline, because I'm going to cover it here. Okay, so what's the difference between a base and an alkaline? Base is a very broad umbrella. Basically, anything that it is a metal oxide or a metal hydroxide, sorry, writing CMI, but anything that's a metal oxide or metal hydroxide is a base. So there's a lot of base. You go to your periodic table, right? All the metal, you add in an O or you add in an OH, it just becomes a base. Okay, now, but there's only a very select group that is soluble in water. Those which are soluble in water are known as alkaline. I repeat again, base is any metal oxide or hydroxide. We generally refer to those that are insoluble as bases. But there's a very small group, when you put them in water, they actually dissolve. Those are known as alkaline. Alkaline would dissolve in water to produce OH minus, as you can see here. Which are the ones that typically form alkaline? Okay, alkaline are typically your group 1, sodium, potassium, or even group 2. Okay, these are your typical ones. Okay, if I'm allowed, yes, alkaline are considered bases. Okay, now, if I use a very math terminology here, right? Alkalines are a subset of base. You get it? Okay. So base is just this big group that encompasses everything. But there's a very small group within these bases that happens to be soluble in water. They are known as alkaline. So if you're thinking of acid, right, the common association between acid is actually with alkaline, because acid dissociates in water to produce H+. Alkaline dissociates in water to produce OH minus. Clear? So if this question appears in the exam, right, make sure you get it right. The difference between base and alkaline. Okay, next. One of the most commonly tested questions, not only at end of year, but during O levels itself, is this. Okay, so you know farmers, right? What they like to do is for the plants to grow well, they like to add fertilizer. Okay, and what's in the fertilizer? The fertilizer typically contains ammonium chloride or some ammonium compound, but it will have this NH4 thing. Okay, then at the same time, because got acid rain and stuff, you know, the soil gets too acidic. So what do? They want to neutralize the acid and they add in alkaline. But what's the issue when we add in these fertilizers that contain ammonium and the alkaline at the same time? Remember earlier we did this equation, the one that asked you to asterisk, right? When we add alkaline to ammonium salt, what happens? It will react to produce what? It reacts to produce salt, water, and ammonia gas. So we put it in context of a real life situation whereby your fertilizer now that contains ammonium reacts with an alkaline, you will get a salt, water, and ammonia gas. And this is disaster. Why? Because the ammonium that was supposedly a fertilizer that is meant to be absorbed by the plants, it would have reacted and escaped in the form of ammonia gas. On top of that, your alkaline that was supposed to neutralize the acid, now it reacts with the fertilizer instead. So you did not neutralize the acid as well. So that makes it very terrible because the crops will not be able to absorb the nitrogen content as is released in the form of ammonia gas. Clear? So that's the reason why we should not add fertilizer and alkaline at the same time. Okay, take note, this is a very commonly tested question. I want you to be very certain of how this works. Okay, some other questions that might be tested just to show you a bit. okay, includes things like, for example, your choice of your, sorry, let me scroll first. I know you cannot see anything yet. Okay, for example, if we want to neutralize the acid in the soil, should we use carbonate or should we use hydroxide? Okay, typically calcium carbonate is a slightly better choice because it will not cause the pH of the soil to increase further. Okay, while if you add in calcium hydroxide, it's bad because it might actually push the pH to the alkaline range. Okay, acid-base, acid-alkaline is always going to be neutralization. All right. Okay, if not, I'm down to my last portion for acid bases. Okay, take note that the last thing you need to know here is your oxides. Okay, there are 4 kinds of oxides. Basic oxide is the same thing as base. Okay, they are basically your metal oxides. Acidic oxides are non-metal oxides. They behave like an acid. Amphoteric oxides means it goes both ways. It can react like an acid. It can react like an alkaline. Okay, so when that happens, right, okay, you need to know that, hey, this one looks very suspicious. Can react acid, can react alkaline. What the hell is it? It is a amphoteric oxide. There's a total of 3 of them in our syllabus: aluminium, lead, and zinc. Okay, I see some questions about what can you add, right? So just to go back, can you take note on the here, this one? pH in soil, right? So we can add carbonate, we can add calcium oxide, we can even add calcium hydroxide. Any of this will help you get rid of the acid and neutralize it. Okay. Okay. Lastly, neutral oxide is your water. Take note, carbon monoxide is neutral. Carbon dioxide is acidic. Nitrogen monoxide is neutral. Nitrogen dioxide is acidic. Clear? So when you're studying, you need to be very precise. You cannot, nitrogen oxide or something. Yes, dioxide and monoxide, it does make a difference. Okay, next. Okay, finishing off, let's talk about salts. Okay, last topic before we end off the chemistry portion. For salts, just make sure you know your salt solubility table. Okay, I know this is something that you need to memorize and it gets quite annoying. Earlier, some of you were asking what is a spar salt, right? Spar salt just means sodium, potassium, and ammonium. Ammonium is NH4+. Okay, take note that anything that has sodium, potassium, or ammonium is automatically just soluble. Okay, all nitrates are soluble as well. All chlorides and sulfates are soluble except for these few idiots. Okay, so these are the ones that you really need to memorize because these are your insoluble salts. Okay, now, just going to give you a quick tip. If you want, you can take it down. How do you memorize things easier? Okay, you should always find a method that works. Okay, so I'm just sharing all of my many memorizing techniques for my sulfates. Okay, so sulfate here is ash, right? So what I think of is science, right? So what science subjects are there? PBC. What do you guess? Physics, bio, chem, right? So science, sulfate, S, PBC, physics, biochem. So this is just one way you can make your memorization process easier. Okay, of course you can find your own method. It doesn't have to follow mine. But all I'm saying is that when it comes to things like memorizing, you should make things easier for yourself by finding a method that works. Okay, so this is just one of the many methods. Okay, why do we need to learn the salt solubility table? We don't just memorize this for no reason. We memorize this so that we are able to decide which method to use when we're preparing a salt. The first method in our syllabus is known as precipitation. So precipitation is used when we're trying to produce an insoluble salt. How does that work? We add 2 things that are soluble to get our insoluble salt. Okay, so for example, what is one insoluble salt that we just learned? Calcium sulfate, right? So if I want to form calcium sulfate, my first soluble substance must contain calcium. So something like calcium nitrate. The next one must contain sulfate. So maybe something like potassium sulfate. What happens is that the calcium will come together with the sulfate to form a precipitate. All I have to do after I mix these 2 together is to filter. My residue is my insoluble salt. So this is known as precipitation. Next. Okay, acid reaction is our second one. This one is exactly the same thing as the 3 acid reactions we studied earlier. Okay, why do I say so? Acid metal, acid base, acid carbonate. So for example, if I need to produce a salt of magnesium chloride, how do I do so? You can do so by simply reacting, because it's chloride, right? You need to react hydrochloric acid. I can react hydrochloric acid with metal, I will get my salt. I can also react it with magnesium oxide, which is a base. I can even react it with magnesium carbonate. So it doesn't really matter whether you choose metal, base, or carbonate. As long as it's a metal plus one of them, you'll get your salt. The moment you get your salt, you filter it, you crystallize it. So heat to saturation, allow it to cool, collect your crystals. Those, I think you kind of know how it works. Okay, but at the end of the day, this is merely just an acid reaction. For precipitation, it is soluble plus soluble. So both reactants needs to be soluble for this to work. Okay, now, for the last method, this is known as titration. Titration is when you're trying to produce a spa salt. Okay, the problem when reacting acid and alkaline is that in order to fully neutralize, right, I need to know exactly how much acid I need and how much alkaline I need. So the whole purpose of titration, okay, for those that have done it in the lab, right, why do you drip so slowly? Is because you're trying to find this thing known as the neutralization or the equivalence point. This is the point at which all the acid has fully neutralized with all the alkaline. So the first time you're doing your titration, you're trying to find out where this point is. Then you note down the exact volume of acid and alkaline that you use. The second time you repeat the experiment, you do it without the indicator. That's when you form the exact amount of salt with water. What do we do after that? We undergo crystallization as neutral. Okay, so just to summarize, right, when do we use which method? Precipitation, we use it when we're producing an insoluble salt. Acid reaction, we use it when we are preparing a soluble salt. Titration, we do so when we're preparing a spa salt. Okay, so knowing when to use which method is just as important. Okay, and with that, we come to the end, okay, of the salt preparation portion and the whole chemistry portion. Titration, yes, it could be tested as part of your practical as well. Okay, but before we move on to the next segment, I just wanted to do a quick segue here. Earlier, when you were signing up, I was just checking how many of you were actually having tuition. And I realized that actually a good majority of you are actually not having tuition. I think that's fine. No issues here. But I just was wondering if for some of the upcoming activities that we have, maybe you'll be keen. Okay. So just to share a bit more, that usually before Sec 3s enter the Sec 4 year, I usually start a whole new enrollment. So I like to teach Sec 4 students and prepare them for their O level. So if you're taking pure chemistry, pure physics, or combined science, this is something that you can consider. The sessions are conducted in group sizes of around 5 to 8. It's a weekly 2-hour lesson. And when would this start? Okay, this would start only in the 3rd week of November. Okay, for IP students, I would say that not usually the case, but because the syllabus is going to be different. Okay, so some of the questions that y'all would have next, right, is where is it? How much does it cost, right? So for the group tuition, there are a couple of locations all over Singapore. So we have a place at Toa Payoh, Hougang, Yishun, East Coast, and of course, if you prefer an online option, that's available as well. Now, the fees is fixed at only $40 an hour. This includes all learning materials and your practice worksheets. The learning materials also mean that you will receive the latest edition of the chemistry and physics curated notes. And on top of that, if you are my student, you actually get 50% discount for all crash courses that you can sign up for next year, assuming you're taking it. Okay, I teach at all of these locations. So these are all my group tuition. Okay, and also after every lesson, feel free to, students, they tend to do consultation and stuff. So I'm always available for that as well. Okay, you'll see a QR code sign up form here. If you are interested, you can sign up. But I just wanted to share in terms of during this group tuition, what is it that we typically cover? So right now we're at 2021, O levels still feel quite far away. But the truth is actually 1 year is not that far off. Okay, so if you do join the group tuition in November, what we'll actually do is we'll actually cover some of the older Sec 3 topics that we covered today, all the way up till February for both chemistry and physics. Okay, Then from March till May, we'll actually keep the main focus on the Sec 4 topics that you have learned. This is in preparation of your mid-year exam, because mid-year exams typically in May. Then during the June holidays, in June and July, we'll actually do thematic revision. This thematic revision would be grouping key topics that are interrelated together, and you'll be learning the kind of questions, the hybrid kind of questions that could come up. And from August onwards, which is where all of my students are at right now, the 20 plus so of them right now, they're under exam preparation mode. So we're doing a lot of prelim papers, breakdown, time practices, and also learning important exam techniques and question analysis, and also identifying what are some of the more commonly tested questions, because this will be the kind of questions that they will see in the exam. Okay, some of the questions that I see in the group chat is 2 hours physics and chem together. Usually I'll teach them separately. So physics lesson is just physics, chem is just chem. If you are a chem bio student, pure chem, you can just join the pure chemistry session. If you are taking combined science, then it will be for combined science, chem, and physics. Okay. So if you don't want to do online, definitely that's fine. Okay. So under the sign up form, if you go in, right, there's a list of locations as well as the timings in which is available. Typically for weekday is during the evening and at night. And on Saturdays is from morning all the way to afternoon. So those are the timings for the group tuition. Okay, there's a few options here. So if you are really interested in working with me and you really want to guarantee your spot, you can sign up now to guarantee that you will be in one of my group tuitions. Location will depend on the majority. And from there on, straight away, I'll guarantee your spot and I'll immediately send you a copy of the curated notes so that you can study in advance for your end of year exam. Officially, the lessons will only start in mid-November, but during now till your end of year, feel free to consult me for Zoom consultations. So this is on the basis if you're guaranteed that you would like to be under my tutelage, then I'll be happy to help you out as much as possible right now, right before your end of year. Okay, but I know for majority of you, you might not be so certain yet. So the other option that you could do is to sign up for the free trial lesson. Now, the free trial lesson will also be during mid-November onwards, so you can attend it during your holiday. This first session is entirely free, okay? And if you want to, in fact, it will be more fun, right, to just come with your group of friends, okay? Experience how the lesson is going to be like. Then you can then decide whether you want to continue or not, right? So under the form as well, if you go and scan the sign-up form, you will see that there's an option to indicate that you're going with your friends, okay? Even if you're not too sure, you can sign up first. And then later on, when I reach out to you, let me know that you have a couple of friends joining, or some of you are friends and you want to come together. Then I think we can find one of the common locations to do it. And then we can have a free trial lesson to see if you enjoy it. You can decide afterwards whether you want to join the camp tuition or not. Okay. Yearly wise, I normally only take in around 20 to 25 students because I want to ensure that they have the ample attention that they need. So if you really want to work with me, do sign up now. Okay, but if you're still uncertain, I say try it, sign up, try the free trial lesson, see if you enjoy my teaching, then you can decide afterwards. Okay. The Zoom consultations are free for my students. So students that I teach personally in my group tuition, I offer them free Zoom consultations whenever they need to. Okay. If you just want to attend the chemistry portion, you can just indicate the chem part, and then you just need to attend the chemistry lessons. So the group tuition are split in terms of chemistry classes, physics classes, combined science classes. So for combined science classes, it's chem plus physics. Okay. If you have any questions, you can ask me in the chat now. Okay. Free trial lessons, take note, even though you sign up now, the free trial lessons only going to happen in November and December. Okay, and the first session is free. So if you want to, you can just come and chill a bit, talk with me, but up to you. Okay, the fees is $40 per hour. Okay, I usually only collect fees at the end of every month. How many free trials can a group of friends get? I mean, if you're coming for physics or chem, you probably just need to attend the lesson once to get a feel of it. So I'll say one free trial per group of friends. Okay. I don't do bio because bio is another tutor, but if you're interested, you can also let me know. I can refer to her as well, but mainly for myself, because I specialize in chemistry and physics. Okay, per month depends on how many weeks. So it's a weekly lesson. So sometimes it's usually 4 lessons a month. Rare cases is 5 lessons a month. Okay, this recording will be uploaded on YouTube, no worries. Okay, so I'll attend any other questions for the tuition. If not, I would move on to talk about the physics segment already. I will upload the slides on Telegram. There's also an N-level group tuition option. So you just need to go onto the sign up form and sign up. Okay, the physics sessions will start at mid-November. Yes, the lessons are at spatial. So if you are not certain, right, this classroom here, this is spatial collective. So we will have all our lessons at spatial collective for at least for the Hougang and Toa Payoh groups. Okay. So it will be 2 hours for chemistry and another 2 hours for physics. Yes, because chem is chem, physics is physics. No, you don't have to pay anything when you attend the trial lesson. Like, it's literally free. Okay. Free Zoom lessons only for my students. Yeah. Okay, it's not for everybody. How many packs per group? As mentioned earlier, for the classes is typically between the size of 5 to 8. Okay. It will just be me teaching, so that I'll be the only teacher. Okay, for the Yishun one, I'll also text you all the location. If you are signing up for the free trial lesson, is just go to the sign up form. There's an option to opt for the free trial. You just need to indicate and I'll contact you in terms of the day and time. How do you indicate you only want to go for chem? You can just put in the comment section. Okay. Okay, for the Zoom consultations only for my own students. It's not for everybody. I won't be able to do that. Okay. For IP, you can put in the comments and then we can address it. Okay, then online tuition, same thing. You just need to indicate your preferences. All right. Okay, but it's usually more fun to join with your group of friends, lah. Like honestly, because the groups that I'm teaching now, they are all like friends. So each lesson is a bit more fun. But if you're solo lone warrior, it works too, lah. Don't be worried, cause can make friends. If you take pure, can you go with your combined friends? Sure. You just need to let me know what topics we'll be covering then. Okay. Okay. I think that's about it for the group tuition portion. If anything, you can feel free to message me on Telegram, or you can under the sign up form put in the comments if you're keen. I will do as much house lessons as you guys want to, but normally when I hit my capacity limit of 20 to 25 students, I will actually cut off the intake. So I will normally stop taking in students then. So if you are keen, do sign up earlier. Like I say, if you sign up now, you will receive the curated notes. On top of that, you also get free consultations before your end of year. But the official lessons will only start in mid-November. Okay, can I? So anything, just sign up. Send the sign up form link later in the Telegram channel. But let's focus back on what we're going to cover. Okay, so up next, for my chemistry students, for my physics students, now's the time to do physics. Okay, for my bio students, up to you whether you want to stay. As I said, at the end of the session, there's going to be a giveaway contest. So you might want to come back then, okay, to take part in the quiz. If you win the quiz, you get a free curated notes. Okay. Now, for the physics topics, you'll be covering on a couple of topics from kinematics to forces, to moments, to work, energy, power, and thermal physics. So next, let me go through them. Okay. So first topic we're going to talk about is kinematics. So for kinematics, just take note that one of the biggest points that will be tested will be your scalar and vector, the difference between distance, displacement, speed, and velocity. Okay, take note that distance we do not consider the distance, we do not consider the direction, we only care about the magnitude, while displacement takes into account the direction. Same for speed and velocity. Okay, velocity, directions involved. Acceleration, just take note that the formula, okay, is v minus u over t. V is final velocity over initial velocity over time. Okay, so that's scalar vector for you. Okay, one of the most commonly tested questions that you should expect is the velocity time graph. Okay, so for velocity time graph, how it works is that when you see the graph, you must always check your y-axis first. If your y-axis is velocity, then these are some of the deductions and analysis that you need to make. There's two of them. The first gradient represents acceleration. So you notice here, right, from 1 to 2 seconds, can you see that it's a straight gradient? Constant gradient. Okay, since gradient represents acceleration, constant acceleration is seen here from 1 to 2 seconds. And when it is constant, like it doesn't move, the gradient is flat at 0. It just means it's moving at constant velocity, right? Then from this part here, based on the curve, do you notice if we draw in the tangent, can you see the tangent is actually decreasing? So this is when we need to be able to describe it as it's decelerating at a decreasing rate. But take note, even though it's undergoing deceleration, it is still moving in the forward direction. Okay? A good analogy is that when the car approaches a traffic light, right? Remember, the car is still moving forward, right? It's just that it's coming to a slow, right? So it's slowing down, but it's still moving forward. So take note, never confuse deceleration with moving backwards. Okay? So deceleration is just my speed or my velocity decreasing. I'm slowing down, right? So Usain Bolt, when he runs his race, right, he accelerates at the start of the race, right? Then once he's at top speed, that is constant velocity. And when he passes the finishing line, that is when he slowly slows down, right? Until it comes to a stop and does his pose, right? So that is deceleration. So deceleration is just the opposite of acceleration. All right. Now, something else I need you to note is that the area underneath the graph represents displacement. Okay, what do I mean by this? Take note, you take a look at area X. Do you notice it's above the X-axis? Right. So for Jewel, your question is, how do you know whether it's forward or reverse direction? It depends on whether it's above the X-axis or below the X-axis. So if it's above the X-axis, this means it is moving in the forward direction. So anytime from 0 to 7 seconds, this entire duration, he was moving in the forward direction. From 7 to 10 seconds, because now the velocity is negative, he's moving in the backward direction. Clear? So if you're calculating displacement, you have to take the area of X minus the area of Y to find the total displacement. Okay, retardation is the same thing as deceleration. Okay, area underneath the graph is your displacement. If you're calculating distance, you should take X plus Y. Because distance, I don't really care about which direction I'm going on. As long as I'm traveling, that's distance. Okay, negative acceleration is deceleration. All right. Okay, another concept that you'll see quite commonly is terminal velocity. So how terminal velocity works is that when something is experiencing free fall, like your parachutist jump out, right? It's like, wee, jump out of the plane, right? What happens? He will start to accelerate because of gravity, right? But it comes to a certain point, right, where his acceleration suddenly becomes 0 and his velocity is constant. This is known as terminal velocity, okay? Terminal velocity occurs, right, when the resultant force is 0. When would that happen? When your weight is equal to the air resistance. So your weight is cancelled out by air resistance. You do not have any resultant force. Since F equals to 0, your acceleration would be 0. Something that does not accelerate moves at constant velocity. This is otherwise known as terminal velocity. Okay, so this is terminal velocity. Then just take note, if I have two objects of the same size, but one is heavier, they will undergo the same acceleration. Why? Because all objects on Earth experience the same amount of gravity, right? Gravity is equal for everyone. Gravity is just 10, right? So initial acceleration would be the same. But the heavier object, okay, would have a higher terminal velocity. Okay, air resistance is a resistive force, is measured in newtons. Why does terminal velocity occur? If an object is falling long enough, when velocity increase, air resistance increase. Until a point where your air resistance is equal to your weight, your resultant force is 0. That is why your terminal velocity kicks in. Okay, so somebody that's falling off Taipei 101, right, doesn't mean they keep accelerating all the way down. It will hit a point whereby they just fall at a constant speed. Okay, so these are the two questions I warned you already. Velocity time graph, terminal velocity. Very strong likelihood to come out in your exam. Okay. Next, let's move on to forces. For forces, I'll keep it basic. Okay, I'm going to talk about the Newton's law. Newton's first law, okay, make sure you know it. Okay, but take note, at O level, you do not need to memorize Newton's law. which means the question will only test you the application of it. Like what affects inertia, for example. But they won't ask you to regurgitate Newton's first law. Okay, so this is not about memorizing, this is about understanding the concept. Okay, now what is Newton's first law? Is basically inertia. If you do not understand inertia, I always say just think of momentum. What is momentum? Basically, if your object is not moving, is stationary, it's hard to get it to start moving. But for something that's already moving, it's hard for it to stop, right? Case in point, right? You haven't started studying for your end of year. Is it easy to get started? No, it's not. That is inertia, okay? But for some hardcore students that are already studying super hard, is it easy for them to stop? No, it's not, okay? That is inertia, it's momentum, okay? So when the driver is driving the car, right, his body is moving forward, but suddenly he's forced to brake, right? Because he jammed the brake, then the seatbelt activates. But during that instance, right, when he jammed the brake, his body still wants to move forward, right? Because an object in motion will continue its in motion. Okay, so that's the reason why his body will lunge forward. Okay, so that is Newton's first law. Basically, you need to know the term, what inertia means. Take note, the only thing that affects inertia is the mass of the object. So an object with greater mass would have greater inertia. Okay, Newton's second law is it can be easily summarized in terms of F equals to ma. Okay, but take note, not F equals to ma. I always ask my students to memorize RF equals to ma. And if you're guessing what RF means, RF is talking about resultant force. Okay, why is this important? Force and resultant force is different. Resultant force means you already account for all other forces. For example, the question gives you driving force. You need to take the driving force minus the friction to determine what the resultant force is. Or if it's tension and weight, you need to take the tension minus of the weight because they're acting in opposite directions. Only then, when you get that F is then your resultant force, which you use F equals to ma. Okay, this one important. Take note. Write this down if you want to. If an object is moving at constant speed, what does it mean? Okay, constant speed means acceleration is 0. F equals to ma. If my a is 0, F is 0. An object that's moving at constant speed, for example, if my car has a driving force of 7 Newton, why does it move at constant speed? Okay, isn't got force means get acceleration? No, remember we talk about resultant force? Because his driving force is 7 in the forward direction, but he experiences an equal and opposite force in the reverse direction due to friction, his resultant force is 0. Acceleration 0. Move at constant speed. This is one of the most classic questions. Like, cannot emphasize how important this question is. Okay, commonly tested. An object moving at constant speed has 0 acceleration. It has 0 resultant force. Okay, so that is for Newton's second law. Okay, if not, let's take a look at Newton's third law. Newton's third law is about the fact that for every action, there's an equal and opposite reaction. Okay, what this means is that for somebody that is pushing off the wall is also pushing off the lady. Okay, so equal and opposite, you can think of it. You know, you play the game, right? Two people stand there, then they try to push each other. So when you push the person, right, you will feel yourself moving back as well. Why? Because when you push the person, technically the person is also pushing you. That is Newton's third law. Okay, so when this swimmer kicks off the wall, she kicked the wall, but actually the wall also kicked her. That is Newton's third law. Okay, equal and opposite reaction. Okay, and lastly, to sum up, okay, what else? Okay, you need to know that one of the more commonly tested one would be friction. You need to know when it's useful, when it's a nuisance, and how to reduce friction. But all this you can read through on your own. I'm not too worried. Okay, but just take note, for a person that's walking, this is a very common mistake. We think that because the person is walking to the right, the friction is towards the left. This is not true. For a person to be walking towards the right side, the shoe needs to generate a frictional force against the ground in the same direction. This is also known as traction. So for a car or for a person to be moving forward, my resultant force has to be in the forward direction. Where does this resultant force come from? It comes from the friction generated between the sole of the shoe and the ground. So for sports players, you all know what I mean. So for myself, I play floorball, right? So floorball is played in the indoor court. I need a good shoe with good grip, right? What do we mean good grip? Badminton players will know as well. It's the cutting underneath the shoe. So how does that affect? For a good shoe is able to generate good friction. That's because it's very sticky, right? It can generate good friction against the floor. That allows you to accelerate and burst off in a certain direction. But some schools, the ground them lousy, right? Too smooth or very dusty. Then that's when it gets very slippery. Then you're not able to move around as fast. So whenever we're generating traction, friction is always in the same direction as where we're moving. Okay, so make sure you get this right in the exam, yeah? Okay, next thing, moments. Okay, moments is F times D. Just take note, this D is your perpendicular distance. Principle of moments will be tested. So they will literally ask you stick principle of moments, 1 mark. Okay, then you just need to know principle of moments. Okay, is defined as when an object is at equilibrium, sum of clockwise equals sum of anti-clockwise. Okay, what kind of questions will come out? The questions can either come out whereby they give you the pivot, right? They give you the force, give you distance, find the unknown distance. This is easy. Okay, next, if you have a question whereby it's hanging by 2 strings, jialat. Why? Because this one means there is no pivot. Okay, what do you do? In this case, if you want to find the force at B, you let A be the pivot. If you want to find the force at A, you let B be the pivot. Then you should be able to find your answer. Okay, but this one a bit more high level. Usually I like to re-emphasize this only in upper sec. At lower sec, hopefully your teacher don't torture you. They only give you the more simple scenario one here. Okay. But I think another key concept that you want to take note of is stability. Okay. So for stability, just take note that there are a few definitions that you need to be aware of. That includes center of gravity, and it also includes stability. So there are 3 types of stability in the form of stable, unstable, and neutral. Stable means I tilt it a bit, it doesn't topple. Unstable means I tilt it a bit, it's going to topple. Neutral means even if I push it, doesn't matter, it stays in its new position. One of the most common examples for neutral equilibrium is like a ball, right? A ball, you kick it to a new position, it just stays there. That is neutral equilibrium. Okay, so that's the difference between the 3. The explanations you can see in the notes, so I will not go through in too much detail here. Okay, in general, you need to mention whether the center of gravity falls within or outside the base area. The moment it falls outside the base area, a moment will be generated, causing it to topple. Okay. Okay, next topic 4, work, energy, power. Okay, for energy and work done, I need you to note energy units is what? Joules. What is work done unit? Work done, yes, we can write it as Newton meter, but actually work done unit is also joules. So what does that mean? Energy and work done is the same thing. What's the relationship between the two? Okay, we typically use energy to get work done. Energy is defined as the capacity to do work. What forms of energy, okay, would they mainly be testing you on? There's only 2, right? KE and GPE. KE is half mv square, GPE is mgh. Okay, what kind of questions can we see, right? The roller coaster law, go up, GPE, go down, GPE convert to KE. At the lowest position, max KE. Then go up, GPE increase again. So that's how it works, right? Gain and loss of energy. Same thing for pendulum bob swinging. Here you have max GPE. When it's at the lowest point, it's max KE. Here is GPE again. Okay. Then in terms of work done, it's also F times D, but the D here is not perpendicular distance, but it's actually the distance moved in the direction of the force. So for example, this example here, we see the box overcoming friction to go up, right? So the work done here will actually be 5 meters times 3 Newton to give me 15 Newton meter. But take note, when this box moves up, it also gains GPE. So we also need to do MGH to account for the increase in GPE. So the work done here is work done against friction plus work done to increase the GPE. Okay, so that is energy work done. Okay, and take note of the formulas for KE and GPE. A lot of times it's an object dropping, then they change the GPE that it had. It will all be converted to KE. Okay, lowest point is max KE, highest point is max GPE. Yep, that's correct. Okay, and the last thing we need to learn, okay, is power. Okay, there are two formulas here. There's power and there's efficiency. Let's take a look at this question together. Because nowadays we always order delivery, right? So Ninja van driver. This Ninja van driver is 60 kg. He's delivering something that's 25 kg. Okay, the flight of stairs he needs to climb is 30 meters. He does so in 2 minutes. Okay, so what do we do here? What is power? Power equals to work done over time. What is my work done? I add up my mass. My total mass is 85 kg. But take note, this is mass. Mass is not useful. We need force times distance, right? So instead of mass, I need to find the weight, which is W equals to mg, right? So 85 kg times 10. 850 Newton. So my F here is 850. How much distance did I travel? 30 meters over time. But why is this wrong? Okay, I want you to pay special attention to this keyword here. Minutes. Minutes. Minutes is the death of me. Why do I say that? Because the time is never in minutes. It's always in seconds. So make sure you don't make this mistake in the exam, right? Because a lot of time we just divide by time, 2 minutes, divide by 2. And trust me, your answer will appear in one of the options. But take note, it's always 2 times 60 seconds. Okay, from there, you should be able to get your final answer. If I'm not wrong, it's A. I don't know, but you'll go and use your calculator and calculate. Okay. Okay. So when somebody's going up a flight of stairs, right, and they ask you to find work done, is always, what's the purpose of climbing the stairs? You want to go upstairs, right? So it's always about increasing your vertical height. That is how we calculate work done for somebody going up the stairs. Okay. Why do we use weight? Because mass is kg, right? Work done is force times distance. The force that we need to push up is equivalent to your weight. Okay, that's why we use W equals to mg as part of our formula here. Another way you could do this question is gain in GPE, but I try not to go that direction because like that one a little bit too difficult to explain. Usually do so when my student master it a bit more, but these are the basics. Okay, moving on to the last chapter already, thermal physics. You ready? Okay, so the first thing you need to learn for thermal physics, one of the major concepts is kinetic model of matter. Okay, in kinetic model of matter, okay, you need to know that there are 3 states, obviously, solid, liquid, gas. Okay, typically schools will test you in terms of the arrangement and the movement. Here is really about the precision of your keywords, right? You say pack closely for solid, lacking a bit. Why? It should be packed closely in an orderly arrangement. Gas should be moving randomly, not just randomly, but at high speed. So what I'm trying to emphasize here is more of like how precise can you be with your keywords, okay? On top of that, if they're asking you a change in state, when solid turn into liquid cause melting, you cannot just talk about the arrangement and movement in liquid state. Remember, when we're describing a change in state, it's always before and after, right? How it changed from solid to liquid, it went from packed closely together in an orderly arrangement to packed loosely together in a disorderly arrangement. Okay, we always need to describe the before and the after. Okay, same thing for movement, vibrating about fixed position to sliding over one another. We always have to draw that. Exactly, this is exactly like chem. So chemistry, we have same topic, kinetic particle theory. This one applies across both topics. Okay, very good spot. All right. So this is what we need to learn about arrangement and movement. Okay. So in your exam, make sure your keywords are right and you describe the before and after. Okay. Now, to talk about some of the more common thermal transfer methods, firstly, conduction. Okay. So conduction is about how you heat up one area, right? They gain energy, vibrate faster, collide with less energetic neighboring atoms, resulting in transfer of energy from hotter to colder area. Okay, take note. I'm going through transfer of thermal energy. There are three methods, right? Conduction, convection, radiation. There are no formulas for transfer of thermal, okay? But what you need to note, right, is that for transfer of thermal, you need to be very careful here because the keywords are king. Okay, so you really need to get the keywords right, which are whatever you see in bold here, these are keywords. So if you see in the curated notes, for example, right, if you have a copy, if you're using this to revise, right, all the keywords are highlighted for you. See? So whatever is highlighted should be in your answer. You'll get it, huh? So this is how we should be revising. Getting our keywords right is so important, especially for thermophysics. Okay, so this is for conduction. Conduction occurs through solid, liquid, and gas. Okay. Next, convection only occurs for liquid and gas. This is about the movement of your heated particles. Okay. Take note of the keywords once again. When a liquid is heated, it expands in volume, becomes less dense, and rises. Cooler and denser liquid sinks. This rise and sink results in convection current. You have to mention the density. Okay. Density is what allows convection to actually occur. So you have to talk about hotter, less dense rise, cooler, denser sink. Okay, so this is keywords as it's most important. All right, so that's for convection. Yes, convection only happens in liquid and air. I actually have a summary slide for this. Okay, just give me a moment. So for radiation, okay, this is the cool one, right? Because radiation is the only process that's able to take place through a vacuum, right? So the sun is so freaking hot. How does the sun energy get transmitted to Earth? It's through radiation. Okay, so radiation can actually occur through a vacuum. It depends on a couple of factors, but the one that will be most commonly tested is the surface color and texture. You need to know that for something that is dull and black, it absorbs radiations the fastest, but it also emits radiations the fastest. Same for the other spectrum in shiny and white. They absorb slow, but they also emit slow. So remember, I take fast, I also give fast. Okay, quick quiz. Why are the kettles or the pots and pans in our kitchen usually silver and shiny? Yes, radiation is part of EM wave. Think about it. Why are our pots and pans shiny and silver? Okay, because usually when we're cooking food, right, what is inside the pot is hot food, right? Like hot soup, right? So the idea here is I don't want my soup to get cold. So I want to emit radiation as slowly as possible because I want it to be a poor emitter of radiation. Here I see a keyword, poor conductor. That is wrong. Why? Conductor is used for conduction, right? Poor conductor means what? It means an insulator, right? But our pot and pan is made of metal. So we shouldn't be using the term conductor here. The reason why it's silver and shiny is because it wants to be a poor emitter of radiation. I don't want my soup to get cold. You'll get a slight difference there. There's a slight difference between the word conductor, emitter, and absorber. Okay, so conductor, we leave it when we're talking about conduction between metals, which are good conductors, versus others they are insulators. For radiations, we use emitter and absorber. Okay, so that is it. Okay, so a quick summary in terms of what we have just covered. Okay, between conduction, convection, and radiation. Take note that conduction only occurs within solid, liquid, and gas. It's the fastest in solid. Okay. Meanwhile, convection only occurs in liquid and gas. In fact, it's actually faster in gas because gas can experience a change in density a lot faster. Okay. And lastly, radiation doesn't even require a medium. Most of the time is about the black, silver, stuff like that. Okay. Oh, Joe, we have a very good question here, which is when do we know, do I use the word emitter or absorber? Just think about your temperature or your object's temperature as compared to the surrounding. If my pot of soup is hotter than room temperature, I'm going to transfer thermal energy away. That is when I'm an emitter. But if my surrounding is hotter than me, I'm very cold, I'm going to absorb radiation. So it depends on your surrounding compared to your object. that's when you know is it an emitter or an absorber. Okay, thermal energy always transfers from a region that's hotter to a region that's colder. That is known as thermal equilibrium. Okay, Ken? If not, we would be down to the last segment, which is the giveaway contest. Thank you for staying until this point. Okay, so this is just to reward y'all. Winner will get a free set of curated notes. Not bad, right? Come for free lessons, still got free stuff to get. Why not, right? Okay. So how would this giveaway contest work? Okay. So we are going to play a simple game on what is it called? Simple game on and Kahoot. Okay. Then the winner will just take it all. That's it. Okay. I'll stop the record.